First is class or struct member statics. So like other languages, there's the concept of member statics. So these are kind of shared. You have a static function and you can have a static variable. The static variable is shared. And you can just have regular variables. In C++, you have header files and you have CPP files. For the functions, you define the body in the CPP file. So this is how you set up a static function, declaration, and then over here is where it's defined. And what's slightly confusing is that in C++, even though we have a static variable here, we still also have to set up a definition here. So we've declared it here and we've defined it here. So that's where the default property goes. And just to show you the static variables, how they work, we can call a static function. There's no object instance here. We can print out a static variable. There's, again, no object instance here. We can create 2 object instances. We can change the static variable, and then I'll print the other instance version of that static variable, and we can see that that value gets changed. So by default, it's 100, and here on this alpha object, I set it to 7, and then I print beta, the beta object, and it's 7. So it was a shared variable. On the alpha one, if I change the member variable to 8, which is by default 0, then print the beta version, the beta is 0. And so that's the difference between member variables and static variables. Additionally, in C++, you don't even have to define the type in the header. The struct or class can be defined in the CPP file up here. So we're declaring the 2 static variables. So here it has declared 2 static variables, but we still have to define them. It declares a struct, then it defines the struct variables below it. And it works the same as before, able to call a static function, read a static variable without an instance, change it for all instances, and member variables work normally. Then there's also function local statics. So here I have a header file with 2 functions. There's an alpha function and a beta function, and it just counts. And inside of this function, we have a local static to that function. It's a counter. We increment it every time the function is called, and this is saved basically associated with this function. Same thing with this beta function. Has a counter, increments the counter every time it's called, and prints out the current count. And so if this run test, I call the alpha one 3 times and the beta one 2 times, and we can see the alpha prints 3 times, beta prints up 2 times, and the variable is incrementing each time it's called. Lastly, there are file statics. So it's another type of static in C++. Here I have a header file and a CPP file, and then a different header file and a different CPP file. This is the alpha files, and this is the beta files. And these CPP files just have a global variable inside of them to this file. And you might expect that this would only be associated with this file, but if you try and compile this, you'll get a linker error saying multiply defined. And so this could have been references externally, and so the linker is calling out that, if you tried to reference these, it wouldn't know which one to do if they were external variables or something. And so what you can do is put static in front of those, and then suddenly these become kind of scoped to these CPP files. I believe the proper term is internal linkage to this translation unit or this translation unit. And now these can have the same name, but different values. And these variables aren't that special. Even though this is static, we can't use it here just implicitly. But what we could do is define this function to get it. So right here, we have a function to get a pointer to this variable. And then I wrote a test over here where we call the function to get a pointer to the static variable, and then we can manipulate it. And ultimately, you can see that the value was able to be changed to 1, 2, 3, 4 using a pointer that we got from a function. And so there's just some nuances with statics in C++. So I hope it helps, and until next time.